Okay, so this says you measure 49 randomly selected textbooks weights and find they have a mean weight of 77 ounces. Assume the population standard deviation is 14.6. Based on this, construct a 99% confidence interval for the true population mean. So notice this is in inequality form. So there's really three ways you can do this, and it depends on whether you know sigma or not, and if you're talking about the mean or a proportion. So if we know sigma, I'm sorry, not sigma, if we know, sigma, then that implies we use a z interval. If we don't know sigma, that implies a t interval. And if we're talking about a proportion, we're going to use a one prop z interval. So here we have sigma. That's 14.6. So we're going to use a z interval. So in my calculator, I'm going to go to the distributions menu. Oops. Oh, I'm sorry, not distribution, stat menu, over to our tests, and we're doing a z interval. We're just going to plug everything in that we have. So we're plugging in data. Our population standard deviation is 14.6. Oh, I'm sorry, we're plugging in statistics because data will be if we were plugging into the list. So here we have the sigma is 14.6. Our sample mean is 77. Size of our sample is 49. And we want a 99% confidence interval. So we'll hit calculate. And we get from 71.628, so 71.63, up to 82.37. Okay, just keep this in mind because this will come up every single problem in this chapter. So now it says you measure 39 dogs' weights and find they have a mean weight of 35 ounces. So that's our point estimate. Good. This is in the margin of error form. Point estimate plus or minus the margin of error. Assume the population standard deviation is 13.1. So we still have sigma. So let's do it the same way we did the last one. Then we can just do a little math to this thing to figure out what we're adding and subtracting from our point estimate. So back to stat, back to z interval. We're going to plug in our values here, 13.1. Average is 35. Size of the sample is 39. And we want 90% confidence. So we'll hit calculate. So now we have 35 plus or minus something to get these two values. So to figure out what I'm adding and subtracting to 35 to get these two values, just take the larger of the two and subtract 35. So 38.45 minus 35 is 3.45. So this should be 3.45. Okay. Question 5 says you want to obtain a sample to estimate the population mean. This formula is taken straight from the notes in this chapter. So it's on page 29 of the PowerPoint notes. So let's send it to the current page. So we have this formula right here. Okay, and it's just a matter of plugging in all of our values and solving for n. So we have our sigma, 62.5. We want to be 99% confident. That's going to be used to find our z, and our margin of error is going to be 10. So I have n equals this whole thing squared. Margin of error is going to be 10. Sigma is 62.5. I'm going to square this whole thing. And then I'm looking for the value of z that cuts off the middle 99%. I'm looking for that z value. So in the calculator, we're going to use inverse normal. The area to the left of this z value, if there's 99% between them, there's 0.5% here. 0.5% here, and 0.5% here. So to the left of this is 99.5%, or 0.995. And it's the standard normal. It's a z-score, so those are going to be 0 and 1. We'll hit paste. So that's our value here, 2.576. Just like that. So I can figure out what this thing's going to be. So I'll take that number, multiply it by 62.5, divide that by 10, and then square it. So I get 259.1. Since we're talking about a sample size, we want to make sure our sample size is always large enough. So no matter what we get for this decimal, we'll always round it up. This is going to be 260. Okay. All right. So it says express the confidence interval 67% to 79.2% in the form of something plus or minus. So we're taking some number and we're adding and subtracting 6.1 to it to get these two values. Basically, I'm looking for the exact midpoint of these two values. So I'm just going to take the average of those two values, 67 plus 79.2 divided by 2. It's 73.1. If I do 73.1 minus 6.1, I get the lower bound. 73.1 plus 6.1, I get the upper bound. So this is going to be 73.1. Okay, I see you found the difference between the two. You need to find the average between the two. Okay, similar idea here, except now they give us the plus minus form. They want us to find the interval. You're just going to take 86.4, subtract it, 86.4, and add it, and those will give you your bounds. The lower bound I'll just do real quick to show you. 86.4 minus 4.5, 81.9. So this will be 81.9. Add it to get the upper bound. Okay, that's all I think you need.